So we're going to take another look at the difference quotient. I believe we only had one example before. There's some examples in the book as well, but probably not very many. First of all, I want to note that the difference quotient sometimes is written like this first one here. Our book is using this, so I'm going to go ahead and use that. You'll notice the only difference is the A is replacing the X. That's the only difference. So not a huge difference. You should be able to do either one, but for consistency, I'm going to go ahead and stick with the one here on the right. Okay, so this is what we're trying to find. Now, I think one of the things that's confusing about the difference quotient is you have this. Okay, so students see that as a formula or a model or whatever you want to call it. It's a bunch of symbols and what does it all mean? And then over here, it applies to a particular function. So it's like, well, there's two formulas, like which one do I use and how do I do this? And maybe it's confusing that way. I'm not sure what part's confusing. Um, but that's kind of my guess is that you kind of have two things going on at once. And you do, and it's complicated. It's a little complicated. So as we pointed out before, the difference quotient, this over here, this is what we're trying to find. The function they give us, that we're kind of used to. We're used to seeing some functions, especially polynomial functions. And they could be even simpler than the one I have here. This is a quadratic polynomial function, but you could make it, just a linear function or something else. It doesn't change how we find the difference quotient, okay? So you're using this function, but you're finding this. This is what you're trying to find. So hopefully that helps a little bit. Now, when you're finding this, there are three pieces. There's this part, f of x plus h. That's the difficult part. F, oh, I'm not liking that pen at all. So I added a couple pens to try to make this a little bit easier for you to see. So we're going to find f of x plus h. And I'm going to write it right here, f of x plus h. So what we're doing is we're substituting x plus h in for x. And so since we do that on the left, we also do it on the right. So it's going to go in here, and it's going to go in here. So now this is going to look like -2, and then I'm going to have the x plus h squared. Now, I have to put that in parentheses, so make sure we do that. Then -3 times the x plus h, and then plus 5. Make sure you write the whole thing. So what you've done is you've written the -2x squared, but you replaced the x with x plus 5, or x plus h. Then here you wrote -3, and you replaced the x with x plus h. And then here you wrote the plus 5, okay? So hopefully you see all those pieces because that's the first part of the puzzle. Now that part, we're going to have to simplify that. So that's going to be, kind of a thing. And then we'll have to find f of x. But you know what? We already know what f of x is. That is right here. They told us what f of x is. And the third piece of the puzzle is down here. It's just h. Okay, it's not f of h, it's just h. Okay? So the hard part is the first part, f of x plus h. We're going to do that now. We're going to simplify it. To simplify, we have to follow the order of operations. We need to square this part. Now, you can write that out as x plus h times x plus h, or you can remember how to square a binomial. So I'm not sure how you want to do it, but that's okay. I'm just going to write it all out. So when in doubt, write it out. Okay. So foiling, I have x times x, which is x squared. I'm going to have x times h, which is hx. I think in the other video I put xh, but really you should go alphabetically. Sorry about that. And then here I have an hx. And then here I have h times h, which is h squared. Now continuing, if I distribute here, I'm distributing a -3. That's going to be -3x minus 3h. And then again, you have the plus 5. So that 5 is not going to do anything for a little while. Whoopsie, I forgot to close off my parenthesis right there. So I needed to put that in. Okay, so continuing on. Now I'm going to distribute this -2. Oh, before I do that, I could do that first, but I'm going to simplify inside first. We have x squared, hx and hx. We have one hx and another hx. That makes 2 hx. Okay, now I'm going to distribute the -2. And I'll get -2x squared minus 4hx. So you're multiplying here. And then minus 2h squared. I'm just writing down the rest of the stuff. Okay, now if you look at this, there are no like terms in there. There's nothing that can be combined. And so that is all the first part. So when I go back up, looking at my difference quotient, that is this part right here. There's more. Now remember I said that part's the complicated part, but that is the first part. So let's go ahead and look at what this looks like. I'm trying to figure out the best way to write it for you. Here's your difference quotient. Feel like this is kind of noisy. Okay, this part, all of that, it's very big, is going to go for right there. Okay, and then the other part, this part, this green box is going to go right there. And then it's all going to be over H. Okay, so let's see if I can squeeze it all in here. Okay, so this is going to equal, I'll try to write it here. The -2x squared minus 4hx minus 2h squared minus 3x minus 3h plus 5. And that's a lot of copying. And sometimes that's where students make mistake. They try to rush through it. Oh, I'm just copying it. But you don't want to do that. And in math, a lot of times we do have to do copy work, where you're just copying down a row or a column, depends on what you're working on, or an expression. And so it's a little tedious, but you want to make sure you're careful because if you have one sign is different or one variable is different, it can change your answer and then not work out. Okay. Then we're going to be subtracting, so minus. Now, where was the original function? That was the green part. Let me scoot back up here. There it is. I want to put this in parentheses, minus 2x squared minus 3x plus 5. And then the whole thing is over h. Okay, so that h isn't going to come into play for a little while, but okay. Now we have the difference quotient set up. We've got all the pieces in place. It's just a matter of simplifying it. Okay, so I'm going to rewrite it without parentheses. I'll keep the color for now so you can tell which is which. -2x squared minus 4hx minus 2h squared minus 3x minus 3h plus 5. And you don't have to do it this way. I'm just trying to make it really clear, like what I'm doing. Okay. Now, when I go to subtract, I'm going to have to distribute the minus sign there. So it's going to become plus 4, I'm sorry, not a 4, plus 2x squared plus 3x minus 5. And then the whole thing is still over that h. Okay, but now we're getting somewhere. Now we want to look for like terms that can combine. So we have a -2x squared here and a positive 2x squared here. Those are going to cancel out. They're both x squared. -2 and +2, and they're canceling out. Then you have this -3x and a positive 3x. Those are going to cancel out. And then you have a 5, and you have a -5. Those are going to cancel out. Now, a lot of times with polynomial functions, and our polynomials aren't huge, I don't think you're going to see one bigger than a quadratic. This is probably as big as you're going to see. A lot of times you'll see kind of a pattern like this, but be careful, check your signs, check your symbols. Okay. Now, what do I have left after that canceling? Well, I've got, I'll do it in purple, the negative 4hx minus 2h squared minus 3h. And then it's all over that h still. Now, because it's all over h, we're going to go ahead and in the numerator, each term has an h. So we're going to factor out an h. Okay, so make sure that that's right. So this would be the negative 4hx. This would be the negative 2h squared. And this would be the minus 3h. And it's all over h. But then that's great because this h can cancel with this h. Okay, so our final answer here is negative 4x minus 2h minus 3. I would probably just leave it in that form. It would be good enough for me. Okay, so there's another example with a little more detail on it.